Let me open with a bug that has surprised almost every Python programmer. We write a small helper called log. It takes a message, tacks it onto a list, and hands the list back. The list starts empty by default. Then we call it twice, first with start, then with middle. Here is the puzzle. The second call passes only middle. We never handed it the first list again. So what comes back? Just middle, on its own? Or start and middle together? Astonishingly, you get start and middle, both of them. The list from the first call quietly survived into the second. To understand exactly why, we need three ideas: how functions run, what scope means, and the trap hiding in that empty list default. By the end, this bug will feel inevitable. So, what is a function really? Think of it as a reusable machine. You define it once, then feed it inputs, and it produces an output. Here is the anatomy. The word definite announces a new function. Next comes its name, power. How we will call it later. Inside the parentheses sit the parameters, base and exp. These are the named slots waiting for inputs. When we actually call the function, the values we pass in are called arguments, and they fill these slots, and the body runs when called. Return ends the function and sends one value back to whoever called it. This machine raises base to the power exp and returns that result. Now watch what happens when a function is actually called. This is the picture that makes everything click. We call square of 4. At that instant, Python opens a brand new box, a call frame, just for this call. The argument 4 binds to the parameter n. So inside the frame, n equals 4. This frame is the function's own private workspace. The body runs line by line. Result equals n times n. That is 4 times 4, 16. This new local variable, result, lives inside the frame too. Then return hand 16 back to the call site. And here is the crucial part. The moment the function returns, its frame pops and disappears. N and result vanish completely. Only the returned value survives, flowing into answer. There are three ways to hand arguments to a function, and one small twist. Let's use power, but now with a default. exp equals 2. That default matters in a moment. First, positional arguments. Power of 5, 3. Order decides the mapping. Base takes 5, exp takes 3. 5 to the third is 125. Second, keyword arguments. Power. exp equals 3. Base equals 5. Now the names decide the mapping, not the order. So even written backwards, we still get 125. And third, the default. Power of 5 with no exp at all. The missing argument falls back to its default, 2. So 5 squared, 25. Defaults fill the gaps you leave. Tomorrow you will meet often. A star before a parameter, star args, collects any extra positional arguments into a tuple. Double star quarks collects extra keyword arguments into a dictionary. Together, they let a function accept as many inputs as you like. Total of 1, 2, 3 simply sums them to 6. And the twist. What if a function has no return? Show just prints its input. Calling show of 10 does print 10. But result. What show handed back is none. A function with no return statement always returns none. Printing is not returning. Scope is simply where a name is visible. When Python meets a name, it searches outward in a fixed order, remembered as ELGB. First local, names inside the current function. Then enclosing, any outer function wrapped around it. Then global, the top level of your file. And finally built-in, Python's own names like lay and print. The first match wins. Now the idea that trips people most. Shadowing. At the top level, global x is 10. Picture it living in the global frame. Inside f, We write x equals 5. This does not touch the global x. Assigning to x inside a function creates a brand new local x living only in fs frame. The two x's are completely separate names that happen to share a spelling. So f returns 5, its local value. But the global x is untouched. It is still 10. Local assignment shadows the global. It never overrides it. What if you genuinely want to change the global from inside? You must say so out loud. The keyword global x tells Python, do not make a local. Reach up and rebind the real global x. Now x equals 5 inside g actually changes the global. Run g and the global updates to 5. One clean rule to remember. Reading a global needs no keyword, but reassigning one from inside a function needs the global declaration. Now the most important gotcha of all. What really happens when you pass a value into a function? It depends entirely on whether that value is mutable. Start with an integer. N is 5, pointing at the number 5 object. Call bump of n. The parameter k starts out pointing at the very same 5. But inside, k equals k plus 1 rebinds k2, a fresh 6, a different object. The original 5 never changed. An integer is immutable. You cannot alter it, only point elsewhere. So n outside is still 5. Rebinding a parameter is invisible to the caller. Now a list and everything flips. Numbers points at the list 1, 2. Lists are mutable. You can change their contents in place. Call add3 of numbers. The parameter lst points at the exact same list. 2 names, 1 object. There is no copy. Now lst.append 3 mutates that shared list in place. And because numbers points at the very same object, numbers now reads 1, 2, 3. The change is fully visible to the caller. Mutating reaches through. Rebinding does not. Before the trap, one warm-up that ties scope and defaults together. Power and shift squares base and adds the global x. First call, power and shift of 3. exp defaults to 2. So y is 3 squared, 9. X is read from global, 10. Return 9 plus 10, 19. Then we reassign the global x to 5. Second call, base 2, exp 3. Y is 2 cubed, 8. And because x is read fresh from global each time, it is now 5. Return 8 plus 5, 13. Notice the same function gave different answers because it reads a global that changed. Now the trap itself. Collect appends a value to data and returns it, and data defaults to an empty list. Here is the secret. That empty list is created once, when the definite line runs, and stored on the function. Call it L. Every call that emits data reuses this same L. A equals collect of 1. Data is L. We append 1, so L becomes just 1. A points at L. B equals collect of 2. Data is that same L again. Append 2, L is now 1, 2, and B points at L2. But C equals collect of 3, and this time we pass our own empty list. So data is a brand new list. M, not L at all. Append 3, M is 3. C points at M, and L is left completely alone. Still 1, 2. Finally, D equals collect of 4. No list passed. So back to the default L. Append 4, and L becomes 1, 2, 4. D points at L. And here is the sting. A, B, and D all point at this very same L. They are not 3 separate results. They are 3 names for one list. The fix is a reflex worth building. Never use a mutable default. Default to none instead. None is immutable and safe. Then inside, if data is none, make a fresh empty list. Now every call that emits data gets its own new list. Collect safe of 1 gives 1. Collect safe of 2 gives 2. Independent. Every time. Your turn. Tick uses global count, adds 1 to it, and returns it. We call it 3 times in a row and print the results. Pause the video. Ask yourself, does global count really change each time, or does each call reset it? Predict the three numbers. First tick. Global count goes from 0 to 1 and returns 1. Second tick. Because global keeps the change. 1 becomes 2, returns 2. Third tick. 2 becomes 3, returns 3. So it prints 1, 2, 3. If you predicted that, you have understood the whole lesson. Global truly persists across calls, and each call builds on the last. If you thought it reset to 1 each time, remember, global is what lets the change stick. The number one trap, a list or dict default, is created once at definition and reused every call. Default to none and build a fresh one inside. Rebinding k equals something, lst equals something, only changes the local name. Mutating, append, or lst bracket 0 changes the shared object the caller can see. Assigning to a name inside a function makes it local. To reassign a global from inside, you must declare global first. A function with no return statement hands back none. Printing a value is not the same as returning it. Let's lock it in. A function is a machine, inputs in, one value out. Every call opens its own private frame that pops when it returns. And whenever you pass something in, or lean on a default, ask two questions. Is it mutable? And is it shared? Answer those, and functions and scope will never surprise you again.